Good day, everyone. This day I'm going to explain the K-map. So at the end of the lesson, you're going to explain the difference between the use of Boolean algebra and K-map in simplifying Boolean functions. You can also reduce logic functions using the K-map method, and you can design a logic circuit of the simplified logic functions. Okay, so the Carnot map was developed by Maurice Carnot, who is a telecommunications engineer, and he developed the Carnot map at Bell Labs in 1953. Carnot introduced a method for simplification of Boolean functions, and this method is known as Carnot map or the K-map method. This is a graphical method in which it consists of 2 to the power of n cells for n variables, meaning to say the n represents the number of your variables, your input variables. And the adjacent cells are differed only in a single bit position. So what does it mean when we say cells are differed only in a single bit position? So let us take a look at the 2 and the 3 came up. 2 variable and the 3 variable came up. So we have here for the 2 variable map, example, we have variables y and z. So there is no problem with the 2 variable map. It is because you will only deal with the 0 and 1. So the possible values for y is 0 and 1. And the possible values for z is 0 and 1 also. Now, to get the value of the combinations of your K-map, meaning to say, how are you going to determine the value inside the cell? So for a 2 variable map, this value in the cell corresponds to the intersecting value of the y and z. So for example, for your y, you have 0, and your z is 0. So therefore, you have 0, 0, or that is equal to your m sub 0. Meaning to say, the value of that cell is 0. Now, you have y is 0, and you have y, and z is 1. So therefore, you will have 0, 1, or that is 1. So that's why you have here m1. This means that the value in this cell is 1. Then another one is for your y, which is 1, and your z is 0. So therefore, that is equal to 1, 0, equivalent to 2. So therefore, this cell contains the value of 2. For the last cell, we have here your y is 1 and your z is 1. Therefore, that is equal to 1, 1, or that is equal to 3. That's why the value of your last cell is M3. This means that the value inside here, or this cell, the value is equal to 3 or 1, 1. Okay, so in terms of grouping, the Carnot map, you can only, there is only one possibility for grouping for adjacent minterms for a 2 variable map. Meaning to say, pwede ra nimo, isa lang ang possibility nga mag-group nimo ang upat. Kay upat raman sila kabuok. Maximum nimo na siya nga mag-group sa K-map. By the way, ang purpose of using the K-map is to reduce your expression. Aside from the K-map, we can also reduce the expression using the Boolean identities. K-map is just another method in order to reduce your logic expression. So you can choose, you can use the K-map or you can use the Boolean expression. So whichever is convenient to you, so it's up to you. But if the problem asks you to derive the logic expression using the K-map, so therefore you have to solve it using the K-map. Okay. So the possible of combinations of grouping two adjacent mean terms are you can group. So in K-map, you can only group adjacent, meaning to say adjacent tapad. Okay? You can only, in this two variable map, the adjacent terms are M0 and M1, M2 and M3, M0 and M2, and M1 and M3. So, those are the possible combinations. So, either you can group it by 4 or you can group it by 2. Okay, that is the possible combinations of your K-map. Ang question, ma'am, can we group it by 3? No, because grouping of K-map is either by 2, by 4, or by 16. Pwede siya. 8, pwede siya. Pwede siya ang 8. So, grouping of K-map is 2, 4, 8, and 16. But you cannot group the K-map in odd numbers. Okay. Next, we have here the three variable K-map. How to come up with a three variable K-map? So, how do we know that there are 8 variables in a K-map as you have seen in this K-map or in this table? So, to determine the number of combinations of your K-map, you have to raise 2 raised to the power of the number of variables. So, in this example, you have the 3 variables. So, 2 to the power of 3, that is equal to 0. So you have the combinations 0 up to 7. Okay. So in drawing the K-map, you can have this one. You can have it separate ang X and then your Y and Z is grouped. So sa kining example, you have X. What are the values of X? X can be 0 or 1. Now, for your YZ, possible values of y is 0 and 1. Possible values of z is 0 and 1. So since there are 2 variables, so therefore you are going to have the 2 bits. Okay. As you have seen in this table, the first combination of your yz is 0, 0. And then it is followed by 0, 1. But it is not followed by 1, 0, di ba? So you have 0, 1, tapos nag-3 siya, and then nag-2. Why is it? So according to the rule in the K-map, you can only change the bit once. So therefore, in here, sa first example, you have 0, 0. The next one, ang nag-change lang nimo is 1. Di ba? Nag-0, 1 ka? Okay. So sa next, you cannot change this 1. And you cannot change this 0. So therefore, isa lang ka bit ang pwede nimo i-change. So that's why remain ang 1, then you have to change the 0 into 1. So that's why you have 1, 1. And for the last value, remain ang 1, kini siyang the most significant bit, and then change the least significant bit into 0. So, dili siya sa 3 variable map, you cannot have this 0, 1, 2, 3, but you have 0, 1, 3, and 2. Because of, if you're going to have 0, 1, and 2, and 3, you will violate the rule of the 3 variable map. Now, you can only change the bit once. Okay. Now, so we have here the value. X is 0, Y is 0. The value of that cell is 0. Next, we have X is 0, Y and Z is 0, 1. So you have 0, 0, 1. That's why you have here M1 or 1. Then you have your X is 0, Y, Z is 1, 1. So you have 0, 1, 1, or that is 3. Then if you have X is 0, Y, Z is 1, 0. So you have 0, 1, 0. That's why you have M2. Next, we have 1, for x, 0, 0 for yz, you have 1, 0, 0 that is equal to 4. Then x is 1, yz is 0, 1, so you have 1, 0, 1, or that is equal to 5. Your x is 1, yz is 1, 1, that is equal to 7. And your x is 1, yz is 1, 0, that is equal to 1, 1, 0, or that is equal to x. Okay, so what are the possibility or possible groups? So, you can group this one by 8. Pwede mo siya i-group tanan as 8. 8 sila kabuok, pwede. Another combination is you can group it by 4. So, you can group the mean terms nga pwede nimo i-group. You have M0, M1, M3, and M2. You have M4, M5, M7, and M6. You can also have M0, M1, M4, and M5. You can also have M1, M3, M5, M7. You can also have M3, M2, M7, M6. And you can have M2, then you have M0, M6, and M4. Question, Ma'am, is M2, M6, M4, and M0 adjacent? The answer is, in a three-variable map, i-imagine mo na you are flipping a paper. Ang paper nimo, there are 8 cells. If you are going to flip, iabot nimo ang end to end of the paper. So, ang M0 and M2, M4, and M6 will touch with each other. So, therefore, they are adjacent. So, that's why you can group M0, M2, M4, and M6. Okay. So, if x is 0, then 3-variable map becomes a 2-variable. So, kung wala na ning zero, ang x nimo is only 1, kung walay sulod imuhang x nga 0, so therefore, ang mabilin is only M4. You will only have a 2-variable K-map. Okay. Next. The 4-variable K-map. So the same with the 3-variable K-map, with 4-variable K-map, you can only change the bit one at a time. So that's why you have here, so for your YZ, you have 0, 0. Change the 0 into 1, the least significant bit. So you have 0, 1. Then for the third value, you have 1, 1. Remain ang 1, change ang 0. Then for the last value, you have remain ang 1, change the 1 into 0. So, the most significant bit nga 1 i-remain. Ang least significant bit nga 1, pulihan siya og 0. Same with WX. So, you only have also use 0, 0, 0, 1, 1, 1, and 1, 0. Okay? So, possible groupings. You can group it in 16 adjacent mean terms. Meaning to say, you can group it kini silang tanan. I-group nimo. Pwede siya. Then, you can also have, let R1, R2, R3, and R4 represents the mean terms of the first row, second row, third row, and fourth row respectively. So, since C1, C2, C3, and C4 represents the mean terms of first column, second column, third column, and fourth column respectively. So, the possible combinations of grouping 8 adjacent mean terms are 8 adjacent mean terms. So, you have ang first row, kini siya diri, this is the first row, this is R1. Second row is R2, this is R3, and this is R4. So, the 8 adjacent mean terms are R1 and R2, R2 and R3, R3 and R4. Then you have column 1 and column 2, column 2 and column 3, column 3 and column 4, and column 4 and column 1. So, isa na siya. Pwede mo na siya ang pwede nga mga groupings. If your W is equal to 0, then 4 variable K-map becomes a 3 variable K-map. So, kung wala ning most significant bit diri tanan, so therefore, ang mabilin is only X, Y, and Z. So, mahimo na siya 3 variable K-map. Okay. So, sa 5 variable K-map, the number of cells in variable K-map is 32. Since the number of variable is 5, so 2 raised to the power of 5 is 32. So this is an example of a 5 variable K-map. You have variable v is equal to 0, that is 16, and another one is v is equal to 1, that is equal to 16 also. So therefore, you are going to combine the two, you can come up with a 32 uh, combinations. Okay. So, that is for a 4 variable, the 2 to 5 variable K map.